Lesson 9. Working with rational expressions. Working with rational expressions, which includes adding, subtracting, multiplying, and dividing them, is a very important skill that will be very useful later on. So adding, subtracting, multiplying, and dividing rational expressions is a very important skill that we will use soon. Multiplying rational expressions is the same as multiplying fractions, except these fractions have polynomials as numerators and denominators. First, you simplify the operation by dividing common factors. So multiplying rational expressions is the same as multiplying fractions, except these have polynomials in the numerators and the denominators. The first step is always to simplify the operation by dividing by common factors. Then you simply multiply the numerator with the numerator and the denominator with the denominator. So then we simply multiply the numerator with the numerator and the denominator with the denominator. Since you already simplified by dividing common factors, you do not need to simplify the final answer. It is already in simplified form. So because you already simplified by dividing common factors, you don't need to simplify the final answer. Alternatively, you could multiply first and simplify your final answer at the end. Another way to do it is multiply first and simplify everything at the end. However, we don't recommend this because of 4. We recommend simplifying everything at the beginning and then just having your final answer in simplified form. And remember to always state restrictions in your final answer when working with rational expressions. Always state restrictions in your final answers when working with rational expressions. Let's go through a simple example involving monomial numerators and denominators. Simplify the following rational expressions. Simplify the following rational expression and state any restrictions that exist on the variable. 6x squared divided by 3x times 12x squared divided by 2x. First, we'll divide by common factors to simplify. The G.C.F. greatest common factor of 6 and 3 is 3. So the greatest common factor of 6 and 3 is 3. So we're dividing by common factors to simplify. And the greatest common factor of 6 and 3 is 3. So we divide both by 3. 6x squared divided by 3 is 2x squared, and 3x divided by 3 is x. So we get 2x squared over x. And then we just bring over 12x squared divided by 2x. Next we divide 12 and 2 by 2 to simplify. So next we divide 12 and 2 by 2 to simplify, because this is the greatest common factor of these two coefficients. 12 divided by 2 is 6, so we have 6x squared in the numerator, and 2x divided by 2 is x, so we have x in the denominator. So 6x squared divided by x. So we have 2x squared divided by x times 6x squared divided by x. Next we'll simplify variables. Divide 2x squared and x by x, the G.C.F. So next we divide 2x squared and x by x, which is the G.C.F. of these variables. X squared divided by x is 2x. X divided by x is 1. So we have 2x divided by 1, an imaginary 1. Then divide 6x squared and x by x. We bring down 6x squared divided by x. And then we divide 6x squared and x by x, the greatest common factor. So again, we have 6x squared divided by x. X is the greatest common factor. So we do 6x squared divided by x is 6x. X divided by x is 1. And there's an imaginary 1 here. So we have 2x times 6x. We've fully simplified. Now multiply just like a fraction. Just like in a fraction. Note that the denominator is an imaginary 1 which is not written. So the denominator is not written because it's an imaginary 1. So now we just multiply, like in a fraction. 2x times 6x is 12x squared. Finally, state all the restrictions. The only variable present was x. So x was the only variable present, as you see in the denominator. We were checking for all variables in the denominator to see what variable was present in the denominator. We only had x, 3x, 2x, and x present in the denominator. When we set that equal to 0, we get x equals 0. X equals 0 is automatically equal to x equals 0. 2x, when we set that equal to 0, we divide both sides by 2. We get x is equal to 0. Because 0 divided by 2 is 0. When we set 3x equal to 0, we get x equals 0. Remember, the denominator cannot be equal to 0. So we set it equal to 0 and solve for x. The only variable present was x. When x is 0, when x is 0, the denominator had a value of 0. As we already computed that above. And any number times 0 is 0. So when all of these values, x was 0, it doesn't matter what the coefficient was, because any number times 0 is 0. So the restriction would have been x equals 0. Consequently, the restriction is x is not equal to 0. Sorry, the restriction would have been x is not equal to 0. So we set this denominator equal to 0 and we solve for x. So the denominator is x is not equal to 0. So 12x squared, comma, x is not equal to 0 is the final answer. So the final answer with the restriction is 12x squared, comma, x is not equal to 0. By following the steps listed above, you will be able to multiply any two rational expressions. So by following the steps listed above, you can multiply any two rational expressions. Now let's look at a multiplication with rational expressions made up of polynomials with two or more terms. When working with rational expressions, always factor, if possible, polynomials made up of two or more terms before doing anything else. So when working with rational expressions, always factor polynomials made up of two or more terms before you do anything else. This will allow you to easily simplify afterwards, making multiplication easy. So this will allow you to simplify easily, and then that will allow you to multiply more easily. Let us go through an example. A squared plus 2a divided by 3a times 15a squared divided by 5a squared plus 10a. Before we can do anything else, we must factor. Notice that a squared plus 2a can be factored. So we can factor a squared plus 2a. It's a polynomial with two or more terms. And it can be easily factored. We factor out the a. So a times a plus 2 is equal times a plus 2 is equal to a squared plus 2a. So we simply write that down and bring everything down. Divided by 3a times 15a squared divided by 5a squared plus 10a. Note that 5a squared plus 10a, a binomial, can also be factored. Factor it. So in the next step we factor 5a squared plus 10a. is equal to a times a over 2 over 3a times 15a squared over 5a times a plus 2. Note that there is nothing left to factor. Now divide by common factors to simplify. So now we divide by common factors to simplify. Note that a plus 2 can be cancelled out, because a plus 2 is in the numerator here and the denominator here. So we cancel it out, and we bring everything down. A over 3a times 15a squared over 5a. Now divide the numerator and the denominator in the second fraction by 5a to simplify. Note that this can be simplified. So we do 15a squared divided by 5a and 5a divided by 5a. 15a squared divided by 5a is equal to 3a, and 5a divided by 5a is equal to 1. So we bring everything down. Equals a over 3a times 3a. Note that 3a is a denominator in the first fraction and a numerator in the second fraction. Has a denominator of 1. This fraction has a denominator of 1. So we cancel it out. We cancel 3a because it's a numerator in this fraction and a denominator in this fraction. So we bring down the a. Don't forget the restriction. We have 3 polynomials involving a in the denominator in our calculations. So we have 3 polynomials involving a in the denominator in our calculations. We had 3a, we had 5a, and we had a plus 2. So we set those equal to 0 and solve as an inequality. So 3a cannot be equal to 0, 5a cannot be equal to 0, and a plus 2 cannot be equal to 0. Therefore, and now we solve for a. Therefore, the restrictions are a cannot be equal to 0, and a cannot be equal to negative 2. So the final answer, so we have a, comma, a cannot be equal to 0, comma, a cannot be equal to negative 2. So the final answer is a cannot be equal to 0, a cannot be equal to negative 2. Remember to always factor all polynomials made up of 2 or more terms before you do anything else. So always factor polynomials made of 2 or more terms before you do anything else. Also, don't forget to state all restrictions. So always state all restrictions. Notice that when calculating restrictions, you should only look at all factored polynomials in the denominators of both fractions. So when you're calculating restrictions, only look at factored polynomials in the denominators of both fractions. And you should look at all the denominators when calculating restrictions. See, we looked at all the denominators here. We looked at this denominator, this denominator, this denominator, this denominator, this denominator, this denominator. So we looked at all denominators. Dividing rational expressions is very similar to multiplying rational expressions, except that you must multiply the reciprocal of the second fraction instead of dividing. So dividing rational expressions is the same as multiplying rational expressions, except that you multiply the reciprocal of the second fraction instead of dividing. You can find the reciprocal of the second fraction before or after you factor any polynomial that has 2 or more terms. Just make sure you do it before simplifying anything. So you can find the reciprocal of the second fraction before or after you factor any polynomial with 2 or more terms. Just make sure you do it before you simplify anything. Let's go through an example which involves trinomials. (2x squared minus 8x over x squared minus 3x minus 10 divided by 4x squared over x squared minus 9x plus 20. First, let's convert this into multiplication by multiplying by the reciprocal of the second fraction. So that's the first step. Before we factor anything, we should always multiply by the reciprocal when we're dividing. So we should find the reciprocal of this, and we change this to a multiplication sign. We get 2x squared minus 8x over x squared minus 3x minus 10 times x squared minus 9x plus 20 over 4x squared. Now let's factor all polynomials containing 2 or more terms. First, factor 2x squared minus 8x. So we first factor this binomial. We factor it. 2x times x minus 4 is equal to 2x times x, or 2x squared, minus 2x minus 8x, because we have 2x times negative 4 is negative 8x. We bring everything else down. Next, factor x squared minus 3x minus 10, this trinomial, and x squared minus 9x plus 20, this trinomial. So now we factor the trinomials. We bring everything down, we just factor the trinomials. We do what? Two numbers add up to negative 3 and multiply to negative 10. Negative 5 and positive 2 adds up to negative 3 and multiplies to negative 10. Multiplied by each other is equal to negative 10. So we have x minus 5 times x plus 2 in factor form, this trinomial. And then here we do what? Two numbers multiplied added together give us negative 9, and multiplied give us positive 20. We have x minus 5 and x minus 4 add up to negative 9 and multiply to positive 20. So we write x minus 5 times x minus 4, and we bring everything else down. There's no more factoring to be done. Next, we'll simply cancel out x minus 5 from the first, and we'll simplify. So next we simplify. We'll cancel out x minus 5 from the first and second expressions. So we cancel out x minus 5 from this expression, and we cancel it out from this expression, because it's in this numerator and it's in this denominator, and we're multiplying, so we can cancel that out. Bring everything else down. 2x times x minus 4 over x plus 2 times x minus 4 over 4x squared. Then we can further simplify by dividing 2x and 4x minus 2x and 4x squared by 2x, their greatest common factor. So we can simplify by dividing this and this by the greatest common factor, which is 2x. So 2x divided by 2x is 1, and 4x squared divided by 4x squared is 2x. 4x squared divided by 2x is 2x. So we bring down 2x in the denominator, and we remove the 2x from here. We bring everything else down. There is no more simplifying to be done. Now let's multiply. Numerator with numerator, and denominator with denominator. So we multiply. X minus 4 times x minus 4 is x minus 4 squared, and x plus 2 times 2x is equal to 2x times x plus 2. You can leave the answer like this, displaying polynomials in factored form. Now we must list the restrictions. So that we don't need to multiply out 2x and x plus 2. We can leave this answer in factored form like this denominator in factored form. Now we must list the restrictions. So we go back and we check wherever we had x in the denominator. We had x plus 2, we had 2x, and we had 4x squared. And we also had x minus 5. have three polynomials involving x in the denominator. 4x squared, x minus 5, and x plus 2. We also mentioned 2x, but 2x is the same as 4x squared because they are both equal to 0. Because x, when we set them equal to 0, the x has a value of 0 in both cases. So we have three polynomials involving x in the denominator. 4x squared, x minus 5, and x plus 2. So we set them equal to 0 and solve. So 4x squared cannot be equal to 0, x minus 5 cannot be equal to 0, and x plus 2 cannot be equal to 0. So we have our answer, and then we have x, so x cannot be equal to 0, x cannot be equal to 5, and x cannot be equal to negative 2. Now, in the original expression, the denominator in the second fraction could be factored into x minus 5, x minus 4. So we also have to take this original expression into consideration. And we also have to take this original denominator into consideration. So when we factor that, we get x minus 5 times x minus 4. We took x minus 5 into account, but we didn't take x minus 4 into account. So we set x minus 4 equal to 0. So x minus 4 cannot be equal to 0 because it's in the denominator here. So note that we had to factor the denominator to realize that we need to set x minus 4 equal to 0. So x minus 4 cannot be equal to 0. So therefore x cannot be equal to 4. So we added that to our restrictions. Therefore the final answer is x minus 4 squared divided by x minus 4 squared over 2x times x plus 2, where x cannot be equal to 0, x cannot be equal to 5, x cannot be equal to negative 2, and x cannot be equal to 4. Note that when considering restrictions, we must look at all polynomials in the denominator, including the polynomial in the original expression, which was factored afterwards in this case. So when we are considering restrictions, we have to look at all polynomials in the denominator, including the polynomial from the original expression. Next is adding and subtracting rational expressions. To add or subtract rational expressions, you must first find the lowest common multiple of the denominators of the two fractions. So to add or subtract rational expressions, the first step is to find the lowest common multiple of the denominators of the two fractions. Then multiply each fraction in the original expression by a fraction with a value of 1, so that the resulting fractions have the same denominator. So the next step is to multiply each fraction in the original expression by a fraction with a value of 1, so that you get fractions with the same denominator. Now that they have the same denominators, you'll be able to add or subtract the numerators. So once they have the same denominators, you can add or subtract the numerators. You can easily add or subtract the numerators. Let us go through an addition involving monomial denominators. So we have 1 over 5x plus 1 over 2x. So the first step is, first we must find the least common multiple of 5x and 2x. It is 10x. How do we know it's 10x? Because the least common multiple of 5 and 2 is 10, and x doesn't change anything when you add the x. So the least common multiple of 5x and 2x is 10x. Multiply the first fraction by 2 over 2 and the second one by 5 over 5 to get fractions with the same denominator. So our first step is to get fractions with the same denominator, which is the least common multiple of the two denominators. So we want a denominator of 10x. So what times 5x equals 10x? 2. What times 2x equals 10x? 5. So we multiply this fraction by 2 over 2 and this fraction by 5 over 5. So we multiply it. 2 times 1 is 2, 5x times 2 is 10x. 5 times 1 is 5, 2x times 5 is 10x. Now that the two denominators are equal, we can add the numerators. So we do 2 plus 5 is 7. 7 over 10x. Remember to place a restriction on the variable x. Since the variable is not a binomial or trinomial, x cannot be equal to 0. So x cannot be equal to 0 because the variable is a monomial. So this cannot be equal to 0. This cannot be equal to 0. 10x cannot be equal to 0. If we isolate for x, we get x cannot be equal to 0 in all those cases. So all monomials behave the same way. The result is x cannot be equal to 0 in all those three cases. The final answer is 7 over 10x, comma, x cannot be equal to 0. When you are dealing with a variable that is found only in monomials in the denominator, you know that the variable cannot have a value of 0 because any number times 0 is 0. So in this case, we know this cannot be equal to 0. And we know that any number times 0 is equal to 0. So we know that x in all of these cases will be 0. Adding and subtracting with denominators made up of polynomials with 2 or more terms is the same, except you must factor any polynomials that can be factored before you can find out the least common multiple of the denominators. So when you're dealing with denominators with polynomials of 2 or more terms, what you have to do is you have to factor any polynomials that can be factored before you find out the least common multiple of the denominators. Always factor any factorable polynomials before doing anything else when working with rational expressions. So always factor any factorable polynomials first before you do anything else. Let's go through a subtraction with trinomial denominators. So we have x plus 9 over x squared plus 2x minus 48 minus x minus 9 over x squared minus x minus 30. First factor all factorable polynomials. So we factor this polynomial and this polynomial because these two trinomials can be factored. So what two numbers add up to positive 2 and multiply to be negative 8? We have positive 8 and negative 6. So we have x plus 8, x minus 6. What two numbers add up to negative x, negative 1, and multiply to negative 30? We have negative 6 and positive 5. So we have x minus 6 and x plus 5. Now find the LCM of the denominators. X plus 8, x minus 6 is one denominator, and x minus 6, x plus 5 is the other denominator. To find the LCM, simply multiply the two denominators together and cancel out the common terms, the common polynomials. So when we multiply these together, we can cancel out x minus 6. So the LCM is x minus 8 times x minus 6 times x plus 5. We simply combine all the polynomials together and we cancel out the polynomials that repeat. Now we multiply each fraction by a fraction with a value of 1 to get fractions with equal denominators. So now we're going to try to multiply this with a fraction that gives us the lowest common multiple denominator. So that we need x plus 5 to get that. So we multiply by x plus 5 over x plus 5. Here we need x plus 8 to get the lowest common multiple denominator. So we multiply by x plus 8 over x plus 8. Now that the denominators are the same, simplify the numerators. So now we can simplify the numerators. To do this, we can't subtract these two. That's because we can't subtract these two right away. So we need to simplify them. If we simplify them and make them trinomials, then we'll be able to subtract individual terms. So we'll be able to subtract x squared with x squared and so on. But in this form, we can't subtract these two. So we need to simplify them. So x plus 9 times x plus 5 is equal to x squared plus 14x plus 45. And x minus 9 times x plus 8 is equal to x squared minus x minus 72. Now we can simplify the numerators, two trinomials. So now we simplify the numerators. Note that when we're expanding the negative, everything in the second bracket gets an opposite sign. It becomes opposite in sign, everything in the brackets, when we expand the negative. So we get x squared minus x squared is 0. 14x plus x is 15x. 45 plus 72 is 117. Now state restrictions on x. Take all factored polynomials containing x in the denominator. So now we state restrictions on x, and we take all factored polynomials containing x in the denominator. So to do that, we look and we see where we have x in the denominator in a factored polynomial. That only occurs here in the lowest common multiple. So x minus 6, x plus 5, x plus 8. We set those not equal to 0 and we simplify. Factored polynomials containing x in the denominator are x plus 8, x minus 6, and x plus 5. Therefore the restrictions is x cannot be equal to negative 8, x cannot be equal to 6, and x cannot be equal to negative 5. We set these not equal to 0 and we solve for x. Therefore the final answer is 15x plus 117 divided by x plus 8. 15x plus 117 over x plus 8 times x minus 6 times x plus 5, where x cannot be equal to negative 8, x cannot be equal to 6, and x cannot be equal to negative 5. Notice that we multiply the two denominators together and took out any polynomials that were common in the two denominators to get the least common multiple. So to get the least common multiple, we multiply the two denominators together and took out any polynomials that were common in the two denominators. That's all there is to adding, subtracting, multiplying, and dividing rational expressions. And that's all there is for Lesson 9, working with rational expressions. Stay tuned for Lesson 10, horizontal and vertical translations of functions. Also, if you liked this lesson, be sure to like and subscribe. And also be sure to leave a comment down below. Thank you.